Hi everyone, welcome, and first of all, happy Friday. Before I start my speech, I want to talk to SciTech for organizing the conference. It's always good to have a conference on Friday. Uh, I still did not join the SciTech officially, but I was pleased to speak at a conference in the SciTech name. So I'll be joining SciTech in the October. Well, to break the concept a little bit, we thought to add some DevOps topics to the Dev Jam. And since I'm in the DevOps sphere, I thought there is some good stuff to present today. I'll be talking about the serverless technology. So the DevOps as itself is like a main topic for the last 5 to 10 years. And the serverless is, well, not so new, but new. And a lot of people are talking about it on the market. So we wanted to bring it a bit closely to the users and everyone else who are like using or developing serverless. So yeah, today I'll try to demystify a little bit the concept of the serverless, to check on pros and cons, see what are required skills, some considerations, and other bullet points that you should take into consideration when started using serverless. There are many things that are not so foreseeable. So yeah, we put them together and we hope that you're going to like it. So whatever I'm going to tell you today, it comes from my own practical experience. Many hours spent in discussion, improvements, decisions, some problem-facing situations, and so on. And the most important thing, there is learning. Without learning, there is nothing. So the Gartner estimates that between 2020 and 2025, the 20% of organizations globally will migrate to serverless computing. Yeah, we will be here to see if that's going to be the reality, but we can see that companies are definitely moving in a fast pace towards the microservices architecture. On the other hand, nowadays modernization is not so easy. So many companies still struggle to find the best practices and solutions while implementing the serverless. And yeah, companies should definitely, if not yet, started asking questions about how they're going to develop their products. Taking into considerations the big monoliths versus today's microservices. So a little bit about myself. I'm a senior DevOps consultant. I have been in IT for approximately 10 years. I'm also a Microsoft trainer. I teach Microsoft Azure and PowerShell. Those are one of my main skills. In the October, I'll be joining SciTech. I'm really happy to be on that journey. So far, one of the best companies that I'm going to work for. And yeah, I hope that we're going to do a lot of cool conferences together that are going to come. So let's start. First of all, let's break a bit of glass with finding out what is actually the serverless as a concept. So today we can define it as a prestigious technology concept that is used by developers and consumed by other modular systems and users. It enables people to think more about the application itself, the code, and worry less about the infrastructure. And at the end, it always serves some business purpose, in the essence. It's backed up from behind by servers and huge data centers that are interconnected into regions and spanned together with the geography. So even though they're using the product itself, there are still huge servers all over the world that are providing the service to us. In the nutshell, the serverless can be defined as a function as a service concept, and it's aiming to take away everything except the code that you write, basically. So the teams can focus primarily on the application code development rather than managing infrastructure and so on. But that's actually the topic that I'm going to discuss today. There is much more behind the scenes to make this serverless solution enterprise ready for the big corporations. So first of all, building a serverless is not only adopting new architecture. It's much more it's also about embracing new mindset paradigm about the DevOps, agile, distributed systems, and yeah, in the essence, it's one huge modern shift. We can define it like that. Serverless is a real cloud-native model, basically. It is a system orchestrated by the platform itself, and it is capable of automatically recruiting the right amount of resources that your application needs, such as CPU, memory, etc. And it does all of that without some lengthy period, as we are used to in the traditional way. Companies usually opt / decide to use serverless in a couple of situations, and yeah, I could think about a few of them. For example, when you want to decouple the huge monolith into microservice, that's one of the most usual bullet points. You can build highly modular solutions and incorporate external services. You can also use serverless, for example, when you're expecting unpredictable fluctuating workloads, like in either high or low usage, or if you want to process high amount of data from distributed data sources. Most of the cloud providers give out the free runs up to a certain number of cycles. So if you decide to use serverless service, that means you don't necessarily need to pay right away a huge amount of money to experiment with the service and see how it works. That's always good. Especially with the new technologies, people are not so eager to throw a bunch of money before they have like strong proof of concept and understand how the technology works. Those free runs that cloud providers give away are usually free up to 1 million executions. So that's really high number, and different providers have different politics basically in terms of billing, how they're going to charge you at the end of the month. Some of them charge you per cycle. Some of them rather do that a bit differently. They take into consideration runs, duration, and also the resources that are allocated during the run cycle. Of course, also depending on how mission critical is your serverless solution, you can decide to go for a consumption plan, which is, let's say, natively serverless because you pay only for the resources that you use. Or if your serverless solution is really mission critical, you can opt for some premium plans that is going to make sure that there is a number of workers that are always allocated to run the cycles. This is going to save you on a cold start. So in case that your application is being triggered by some event source, you don't need to wait at all if you have pre-warm worker. But that, of course, comes with some outstanding costs. And at the end, the whole purpose of the serverless is to minimize the total cost of ownership. So in the essence, that's a serverless concept. I can define it with one word. Basically, it's I would call it abstraction between the layers. Now we're going to look at what you can opt as a customer in case you want to run the serverless solutions. Me personally, I always try to stay platform agnostic. I'm a Microsoft Azure fan, but of course there are many people that utilize other cloud platforms such as AWS Cloud, Google Cloud, Cloudflare, and so on. So all cloud platforms differ in functionality, performance, and pricing. That's very normal, and it's going to continue to be like that. As we see more and more platforms rising, they introduce different concepts and so on. So it's a one big competition at the end between the cloud providers. In the beginning, as a customer, the choice that you're going to make will significantly impact the roadmap of your software development lifecycle. That's a one big statement. So you should definitely rethink before starting using one cloud provider. You need to take into consideration the long-term commitment for your service. You should evaluate all potential aspects, basically. What are the biggest concerns for your company? For example, if you're going to get the data lock-in or maybe vendor lock-in, that's not really the good thing. So in case you're going to get locked in with one cloud provider, you should definitely think about the secondary option that can help you escape. But nowadays, most of the cloud providers try to stay also agnostic in that sense. So they're going to onboard you as a customer, but also they're going to offboard you in a good way. There are many migration tools that can help you in case you're not satisfied with the service of one cloud provider, so you want to move to the other one. So definitely evaluate things before you say, yes, I'm going to choose this, because it can cost you money, efforts, people, time, and yeah, in business that's not the best thing. One of the famous technologies that we are seeing in our century, besides serverless, that work together with the serverless, is the edge computing. Edge computing is all about the reduction. It's a networking philosophy that brings computing close to the data source in order to minimize the latency and the bandwidth. And it also saves on the energy and the power. Edge computing basically moves closer everything to the end user, and it enables end user to experience faster response while still maintaining the nature of the cloud computing. We can define it like that. So edge computing also brings some security implications with itself, because it runs at the edge. And every single instance that runs at the edge should be small, cheap, sandbox computer, basically. You should not expect some huge monolith or microservices systems to work at the edge, because, as I said, they should be small and sandboxed. In terms of serverless relation, we can use edge computing for, let's say, security checks, to transform some documents, to do some location routing, and so on. Once the code has been deployed, it will be distributed among many locations where the edge computing has its own point of presence, let's say. For example, Cloudflare, it has the edge computing network and it guarantees that it's only 1 microsecond away from all possible internet-facing users. And it also guarantees the cold start, which is under 1 millisecond. So that's quite impressive. There are also other flavors of edge computing that other cloud providers provide. Some of them use the hybrid scenarios, like, for example, Microsoft Azure use Azure Functions, which is integrated with IoT Edge, and so on. As the time is progressing, we see that there are more and more applicable use cases for serverless computing running on the edge, which basically makes it one big success altogether, combining the technology. Furthermore, if you talk about the security and compliance, for many organizations, compliance in general is one critical aspect. In many technology areas, such as the fintech, healthcare, government, and so on. You as a company, you want to make sure that cloud provider that you're going to choose already ensured that data flow and other security controls will help you to, let's say, easily comply with regulations. So you do not need to do too much heavy lifting on your side once you become the customer. Many cloud providers also offer a bunch of compliance certifications. Some of them are really specific to the global regions where the cloud provider has point of presence, and some of them are specific to the industry, depending. That can be healthcare, finance, government, and so on. Also, when talking about the security in the cloud, there are 3 general concepts that people should remember. We can define it like as a physical one, basically that's protecting the assets in the geolocations, controlling the physical entrance to the data centers and all other assets. Infrastructure security, which is actually ensuring that your infrastructure is being patched, so the cloud provider takes care of that. All ports are scanned, and so on. You can think about it. And of course, data and access security, such as data encryption, in transit and at rest, controlling user privileges, and so on. Cloud providers have a little control over the third aspect, which is the data and access security. And by the research, most of the security breaches actually happen because of the third party, which is the user. And the user is not very well secured. So in the cloud, if there are security breaches, mostly they happen because of the third party / customer, which didn't secure his part of the responsibility very well. Despite all these efforts, certifications, compliance, security, and so on, some companies are still hesitant to entrust to the cloud providers and the whole concept of the cloud, even though modernization is very far away in the future. But as a company, definitely before picking up and saying, yes, I want to go to the cloud, you want to ensure that cloud platform that you're using is going to serve the best business purpose for you, basically, and secure your workloads. While picking the cloud provider, you, as a customer, probably want to engage the product team, or let's say the cloud team that's going to help you to onboard to the cloud easily. All cloud providers have their in-house engineers that are ready to help you because you're their customer or maybe potential customer. Of course, everything is about the sales in today's market. So, but this service might bring additional costs that you should be aware of. I can entrust you it's worth of the price. Whenever I have been engaged to work with the cloud provider support team, well, they showed off to be very helpful. And as a customer, when onboarding at the cloud, maybe you're going to bring some unique architectural designs that still might be unknown to the cloud provider besides its maturity. And before then, you make heavy lifting decision that can impact your business. You should do all these steps and say, okay, this cloud provider is right for me. I'm going to use this platform. Yeah. So, and there are also many more considerations that you should take into account before. Now, talking specifically about the serverless, we checked about the cloud platform that you should think about some considerations before moving on. But then if you want to onboard your applications into serverless fashion, you want to make sure that also your target language is supported. Nowadays, yeah, probably most of the top-notch market languages are supported, like Java, PowerShell, Golang, Node, C#, Python, and so on. But it's always wise to double-check if it's available. Some of them are still in preview. Cloud providers seem to be competing also who is going to release fastest the supported language in case there is a new language in the market. So that's something that brings additional, let's say, competition score with the cloud providers. Besides the language support, you want to make sure that all performance implications that might impact your application are considered. Some languages might work faster, for example, on AWS than on Azure, which is kind of normal if you take into consideration what is actually backing up the underlying infrastructure. Besides the language, you also want to make sure that when designing the serverless architecture, that targeted event sources are supported. Some event sources basically can be supported or not. And what are they in the essence? Event sources or triggers are custom events or data that invokes a serverless function. Some events are based on the storage, messaging queue systems, HTTP protocol, and so on. But the events can come also from many other services that are hosted on the cloud. As the serverless architecture are mostly event-driven, you as a customer want to make sure that the event source that you're aiming to use is supported. So it's wise to think about these things as well. Serverless architecture does not preserve the state. It's not meant to be like that. So each function is always completely independent from the others in terms of its life cycles. So if you want to preserve the state, you will need to use some kind of external storage, such as the blobs or the tables, to keep the tracking of your state. For some mission-critical systems, customers do not want to face the cold start time, basically, which is the actual time that it takes to for application to start once it has been invoked. And this cold start is caused in case that your application didn't run for a while. So if it's in pause, it will probably survive the cold start next time it starts. To prevent this, you can, as I said, reserve some premium plans, which are going to make sure that you have pre-warned workers that are going to serve the requests. This is not then serverless anymore, because it is, but it's not. It breaks the concept a little bit, because you're going to pay for resources anyway and not pay for what you use. So yeah, it is serverless, but it breaks the concept a little bit. Each cloud provider also has its own recommendations for language, how you can optimize your application for the cold start duration, basically. How you can speed up things in case you have cold starts. As a best practices, usually your developers should write lightweight code. And in case that functions have heavy dependencies, it will take longer for the function to start and start serving requests. That's something that's very expected. When it comes to concurrency and scalability, concurrency refers to the, let's say, parallel number of requests, executions that can happen at any given time. So if you have 5 functions bundled into one application, concurrency of 5 would mean that your functions can run simultaneously inside your applications. You can probably estimate the concurrent execution count, but this count might be different due to the event source that you're using. Every PaaS or function as a service supports dynamic scalability as a response to increased traffic burst. So in case you're receiving a lot of events, Cloud Platform is going to take care of auto-scaling for you, which is a big charm of the Cloud Platform. Different cloud providers, of course, have different concurrency limits. These are also differences in scaling intervals and modes. It's always wise to perform benchmark and make sure you're satisfied with the performance outcome, basically, before you choose any cloud platform. Building serverless also requires certain skills. In the essence, how serverless is presented to the world is like, okay, you're going to write your code and they're going to run it for you. You don't need to worry about anything. But yeah, we have been talking till now about the offloading and management tasks. But in reality, there is still a lot going on behind. And to make this serverless solution enterprise ready, there are some required skills that should be taken into consideration. Starting with the infrastructure and network, since every single microservice has to be constructed, basically deployed, secured, DevOps teams still have to have solid understanding of infrastructure and all components that are used, including the network, application layer, infrastructure, and so on. If you as a company employ professionals that are familiar with the cloud, but not so familiar with the traditional onboarding of the services in the private cloud, that might bring some challenges, definitely. Especially in hybrid scenarios, when, for example, you're utilizing more than one cloud platform or spanning one cloud provider interconnected with your private cloud, which brings the hybrid. There might be some issues if the people have purely knowledge on public cloud, but not on the private cloud. For deploying the infrastructure and network, you can always opt for tooling as a team. There are numerous tools on the market, and each single tool can help you. Each single tool has pros and cons, and every single one takes the time to learn, of course. Choice that you're going to make at the beginning can bring substantial difference when it comes to velocity of your team, source code arrangement, and so on. And as the final outcome, of course, how long it takes for you to release. Besides infrastructure and networks, of course, all those servers that are backing the serverless infrastructure have operating system installed. And even though it's abstraction layer that stands in between, it's still required to have some operating system understanding to troubleshoot the issues that might occur, like, for example, network connectivity, application issues, if you need to check for logs in case of application failures, and so on. APIs are kind of common example of HTTP-based serverless solution. So either to develop or support this from the operational perspective, you have to have solid understanding also of the web services. Of course, when it comes to continuous integration and continuous development, from the delivery perspective, CI/CD is crucial for your workflow, and that will dictate a part of velocity and the quality of your team. To develop a proper CI/CD that's going to work for you and for itself, there is a time which is necessary to pass to really understand what you need to incorporate, take out, and so on. And there is always space for improvements, always can be better. CI/CD as itself has many aspects, many best practices, and usually consumes times for the majority of the people. Nowadays, it's becoming easier to understand the concept since it's a brand. A few years before, CI/CD was a myth. We can define it like that. For some people, still it is, actually. Current research says that it takes approximately 3 to 5 years for highly skilled company to mature its CI/CD workflow. And me as a professional who is actually consulting the DevOps clients, I can confirm that, because the requirements are sometimes really, really huge and they change daily. It's easy and hard to keep on. And in reality, yeah, a lot of companies really struggle because the requirements and the project velocity does not slow down. There is always more work. People are spread across the projects, and then sometimes you choose, to please the customer and deliver more, but in the back we actually forget the quality. Then when it comes to application testing, many companies are still incorporating test-driven software development, which I also encourage. As a good example, test-driven development should incorporate its own tests also in CI/CD. Teams can sometimes maybe struggle to incorporate this practice due to complexity, which is normal because DevOps teams need to cooperate together. Testers with developers, developers with ops people, ops with people with testers, and so on. When it comes to best practices, that should be incorporated into framework, let's say. It can be simple pipeline, which has a list of tasks that can execute automated testing against different targets, for example. When it comes to security management, the list can be pretty long, of course, because security is a broad concept. So I'm thinking just to summarize some bullet points that touch the DevOps lifecycle of the serverless solution. Teams should have definitely solid understanding of the security best practices in order to develop secure and maintain the serverless solution. Doesn't matter which language is used and in which sphere of the DevOps you're at. Is it fintech or healthcare? Security should be definitely one of the big marks there. If I think about some best practices, those are like segregation of the environments, for example. You should definitely scope the permissions among the resources, administrators, and consumers, which means that you should follow the least privilege. So you should also make sure that there is approval workflow in place across the whole system, so that people cannot just deploy by their own whatever they merge to master. Some other things are, for example, you should store data which is, let's say, confidential in the secure vaults, never inside the repository or in some flat files. You should maybe, or definitely, if I think about it, start thinking, if not yet, about some software that can enhance your secure coding practices at the developer workstation, and some software that can perform static application security testing, interactive application security testing, and so on. Some competitors on the market are, for example, SonarQube, Checkmarks, Contrast Security, and so on. Furthermore, you should definitely think about the vulnerability testing against the application once it has been deployed, to make sure that you're not one of the victims of the famous flaws that are currently on the market. And of course, you should back up your important deployment artifacts from CI/CD system to enhance the security from disaster. Some other things that I can think about is probably aggregating the logging into the CM system, which can improve the visibility over your own landscape, some heuristic knowledge, and easier incident response, let's say. After we bundle all these concepts of infrastructure and network together, operating system, and so on, there comes application itself, right? So you should have a great team of developers that can support the company vision, first of all. Developers should be able to translate customer needs into developed solution, and that solution should be successful software that mirrors the actual requirements of the customer and what he imagined at the beginning. So looking at all these aspects, to develop one serverless solution, you should have omnipresent team from the beginning till the end. They should work together to deliver and achieve the best quality, to foresee some blind spots, make smart decisions, and all that needs to fit the scale, because every door, behind every door, that can be a new challenge for the DevOps teams. Before we deploy any solution, we of course need to think also about the whole architecture concept. So myself as a DevOps consultant, I could think about numerous things that should be there in place before you can deploy any solution. So I'm going to discuss it a little bit and bring it to the table for people who are not so familiar with these concepts. So every cloud environment should have scoped permission hierarchy, or let's say landing zone better. Resources should be deployed into separate environments. Those environments should not have access to other environments, and vice versa. Whole landing zone should be governed by policies, I guess. You can state, for example, the company requirements in the policy in terms of security and operational excellence, which region your workloads should reside at, what are the minimal security aspects and requirements, and so on. You need to think about the naming convention, of course. There should be some automated process that can generate naming for you before you deploy your resources. You should never hard code anything, basically. Naming convention should be solved very early, and I would advise for that to be done at the company level, because it can really introduce some, let's say, problems and overhead later on if you didn't opt for a good naming solution. Furthermore, talking about billing, you should have tagging strategy in place. You should tag your resources per company requirements, of course. That can be per environment, per project, year of deployments, and so on. And this is all because you want to organize easily your bill at the month to see what is incurring costs or what's not, what can be cleaned up, and so on. There's I believe that my internet connection dropped for a second, and I'm back. So, as I mentioned, secure topology of the network is very important. Some of the common scenarios is hub and spoke. Your data should be masked, classified from non-authorized personnel as well. Customer data should not be accessed even by the administrators, so it should always stay private. When I mentioned the masking, masking is used nowadays because of the GDPR regulations, which is a good introduction in the cloud, so it works for you as well. Connectivity to and from the services should be secured, meaning that your backends should never be accessed directly. Rather, it should, the requests to and from your backends should go through multiple layers of security boundaries. For example, web application firewall, API gateways, and so on. Furthermore, you want to make sure that logs are visible and aggregated for the ease of use and audit. These logs are usually about your services and infrastructure, some audit logs, activity logs, access and performance. Basically, who did what over your services, how your services behave, and so on. In terms of authentication, non-authorized access should be definitely prohibited. In case you're using API gateways, keys for the access to the backend should not be shared among customers. Keys should not expose more than expected, basically. And everyone should follow the principle of the least privilege. You should also probably restrict the IP range that can access your backends through multiple security layers. All confidential and configuration data should be stored securely. Access should be passwordless, leveraging identities rather than passwords. Access to the secure vaults where data is stored should be fine-grained, so one identity should not access all passwords rather than just one. Your application should never contain any confidential data in the configuration or application itself, in the application files. Rather, it should reference secure data stored in the vault, basically, and fetch the secrets during its own runtime. Your application also should be well monitored, because running application doesn't mean it's necessarily healthy, right? When I say monitoring, that should include technical and functional monitoring. Technical monitoring basically will make sure that all infrastructure components are vital under optimal resource consumption, while functional monitoring is something else. It will make sure that your application serves the purpose, basically. In the other words, you can test the application by sending some payload and receiving a proper response back. Yeah, and if I think about it, last but not least, there is application tracking. It should always be enabled to track any suspicious or unexpected change. This will give you ability to go back in time and see exactly who, where, and when changed a particular part of your application or infrastructure setting. So we choose the cloud provider wisely. We talk about the required skills that are needed. We plan the architecture for our serverless solution, picked some necessary constraints. And now it comes to actually deploying your workloads once your application is ready. While moving between the environments, in case your company opted to segregate between dev test, acceptance, and production, for example, there might be many dependencies among the pipelines when segregating infrastructure and application deployment. And that might bring some confusion. Basically, many pull requests all over the place. Not all changes get promoted to the production because people are overloaded. And that's a human factor, basically, when moving your application up to production. I saw that also myself multiple times. People are spread between the projects, and we are moving one project, but the second one is also burning and with a high priority. So it's easy to forget something. And how the complexity grows and the high pace of your company, it's easy to forget things. So yeah, the recommendation is stay focused, basically. Try to work at one thing at a time. Don't move too fast. After you deploy your application, you want to perform some operational testing and production testing to make sure that your application is actually ready for go live. So talking about the OAT, which is actually operational acceptance test, after you consider your application as fully deployed, all changes are in master, deployed to production, you should conduct operational acceptance test. OAuth, let's say, serves as a purpose of verifying that all operational excellence is achieved. We can also call it like pre-sales readiness. In the other words, it's like functional testing of the product, non-functional testing of the product. All resources should be deployed to the proper region, have the proper size, naming, expected amount of resources. So you just want to check that like what is deployed mirrors your code, basically. You also want to check for some vulnerabilities, perform disaster recovery scenarios, and so on. After OAuth, there comes the PAT, which is the production acceptance test, and it demonstrates that your product actually fulfills the business requirements. Tester teams should have a list of test cases that can be executed to determine the product readiness, basically. Performance tests also should be conducted to determine if the application is handling the number of requests as expected, which is something that definitely should be performed after every release in case the application is critical for your company and the users. But also ensures that the application will expectedly handle the faulty scenarios. For example, if authentication should be terminated with the proper error code, for example, users should not be able to log in to the system. Also, for example, if you close the firewall port, that should block the connectivity. Your application should not be operational. So yeah, that can be defined as really executing some test scenarios and making sure the infrastructure and application is ready for the go live. When it comes to alerting, you also during the PAT want to generate some alerts, make adjustments in your system that are actually going to break something. So you want to make sure that engineer on duty receives the alerts if something is broken, and that can be properly escalated later on and handled by the system itself. After you finish all these tests, it's time basically to go live. And at this stage, you want to make sure that every new release goes smoothly with a high velocity, and the system keeps running smoothly, of course. And a few last bullets from my experience, like there are always some blind spots in this kind of architectures because it's very abstract. So no matter how well job is done, sometimes there are blind spots, which is normal. Companies that segregate their environments sometimes do not pay too much attention at lower environments. There might be times when resources at lower environments produce a lot of errors due to their serverless nature, for example, retry scenarios and so on. You can imagine that time-based function is triggered like every 5 minutes, and you can forget it for 1 day, and then you can imagine how much errors it's going to accumulate. So basically, if you accumulate a lot of data, you're going to pay for what you use. A lot of errors means a lot of storage, so there might be unexpected bill at the end of the month. My recommendation is always to monitor dev and test as well. Usually developers and people mess around at those environments and they're not well monitored. And if you don't keep an eye on it, maybe they are going to generate a lot of noise and data which are stored at the cloud platform. So at the end, you're going to pay for that as a customer because it's pay for what you use. In case of platform maintenance and service health issues, it's always smart to have your serverless app replicated also over multiple physical servers and instances. Otherwise, you might experience some downtime with your application. Also, some event sources know to behave abnormal that I saw from my experience. For example, at Azure, when utilizing the Key Vault and event grid, I saw multiple events being delivered for one dead letter in service bus queue, for example. So that's about the blind spots. Doesn't matter how well you architect your solution, there might be some things that you didn't see. To keep your loads running, you should consider key rotation. So most of the applications have authentication keys or connection strings that are used to authenticate and authorize the requests from a consumer. To prevent data exfiltration and for your company to achieve the higher level of security, it's advisable to rotate secure entities on
Okay.
When it comes to endpoint monitoring, all application endpoints should be monitored, both technically and functionally, as I mentioned. Running application does not necessarily mean that it is a healthy application, right? So it's your responsibility to supply monitoring requests on a regular basis and make sure application is running smoothly while serving the requests. Most of the serverless solutions are interconnected, let's say, microservices that are composing one bigger system. And if you're testing just one endpoint, that might not be sufficient. So perhaps you want actually to test the whole flow of the application. Most of the cloud providers have recommendations for end-to-end health checks, and health check is usually implemented as another endpoint that cloud platform is going to call. And that can bring the end-to-end result and flow basically to see if the whole traceability and the whole system is healthy. And yeah, there comes the bill at the end of the month with the serverless solutions. So you should ask yourself actually if your serverless solution fulfilled the requirements. Can you optimize your solution for cost and performance, what your new release is going to bring, and so on. So serverless, yeah, it's a great technology, still new, but it's made to make our life easier, definitely, as an abstraction layer. It takes time to grasp it, but as everything else, once you learn it, it becomes very, very easy and satisfying. And of course, in case you're asking yourself how to use serverless and you need some help, you can knock on the Sitex door. We have some experts in-house that are going to help you to achieve high level of excellence. So that's it for me for today. I'll be waiting for your questions and we'll